Alright, hello geometry. So today we're looking at some basic intro to trigonometry stuff, but we're still talking about it with regards to right triangles. So I promise we'll eventually get to things that aren't right triangles. I know you're probably kind of sick of right triangles by now, but for now, today's stuff, this again only works with right triangles. And the first thing that you're probably going to want to jot down so that you don't have to keep coming back to 30 seconds on the video is this. And these are our three, what are called trig ratios: our sine, our cosine, and our tangent. There are a couple others, but right now these are the three that we're worried about. So your sine, your cosine, and your tangent. And you may notice I put some red letters in these fractions here. Our sine is our opposite side over our hypotenuse. Our cosine is your adjacent side over your hypotenuse. And your tangent is your opposite side over your adjacent. And if you put those red letters at the beginning of your words together, they spell out the acronym SOHCAHTOA. SOHCAHTOA. So that's just a nice little shorthand for remembering this if you don't want to jot down the whole thing. If you don't want to jot the whole thing down, maybe just jot down the red letter part so you remember which thing goes with which, because really the big thing here is just not getting them mixed around. So your sine is your opposite over hypotenuse, cosine is your adjacent over hypotenuse, tangent is your opposite over adjacent, and take a second to write those down, or take a picture of it, or whatever, so that you don't have to keep coming back to it. What did Miss Pion say on that whiteboard on the video? Just jot it down, trust me, you're gonna want it. And I'm assuming you've paused the video and jotted it down by now. Because the first thing we're doing with this is if we've got a triangle, we're finding our 6 trig ratios, which is a lot of things, which is why if you've already glanced at the homework in the description, you may notice there are only 6 problems rather than 10. This is why, because on some of them you're finding a lot of things. So this one we're looking for our sine, our cosine, our tangent, and our sine, our cosine, our tangent of both A and B. And which side is which depends on which angle we're talking about. So we're going to look at angle A first. So if this is the angle I'm looking at, your hypotenuse is always your longest side, which is always going to be the side that's across from your right angle. So this is my hypotenuse. Your opposite side is the one that's not touching the angle that you're talking about. So if we're talking about angle A, your opposite side is the one it doesn't touch. So that, in this case, is this bottom one here, which is 8. And then your adjacent side is either the one that's left, or it's the one that's next to, because adjacent means next to, it's the one that's next to your angle that's not your hypotenuse. So this is our adjacent, and that's my cat. Okay, Marash, gotta scoot. Hi. Oops, that made noise. Oh, and there were the 2 of them. Okay. And one's chasing the other. Okay, so our adjacent side and our opposite side are going to vary depending on which angle we're talking about. Your hypotenuse is always your hypotenuse. So if we're looking for the sine of A, remember our sine is our opposite over hypotenuse, which is why I told you to jot those things down. So our sine is our opposite side, which is 8, over our hypotenuse, which is 10. So as long as you jotted those things down earlier, we're really just filling those things in. So opposite over hypotenuse, which is 8 over 10. And I'm not going to be overly picky here about whether you took that and reduced it to 4/5 or whether you decimalfied it into 0.8. Any of those things are fine. So on the homework, when it says write as a fraction and a decimal, pick one or the other, just go with whichever one you like best. In general, I like to leave them as fractions, because this one came out to a nice decimal, but most of them don't, so I would just leave it. If you went ahead and reduced it or you went ahead and decimalfied it, that's fine. Just be aware that the back of the book will have either the reduced fraction version or the decimal version. Okay, cosine is your adjacent side over your hypotenuse. Hypotenuse is still 10, your adjacent side is 6. And your tangent is your opposite side over your adjacent side. And that does it for angle A. So now I'm going to erase these two because if we're talking about angle B instead, those flip. Because if we're looking at angle B, this one's my opposite side. And this one is now my adjacent side. And you may notice that that's going to flip-flop some of our fractions around a little bit. So if we're looking for the sine of B, your opposite side, so our opposite side is now 6. Our hypotenuse is still 10. So your hypotenuse doesn't change. So your number on the bottom of your sines and your cosines should be the same regardless of which angle you're talking about. That should always be your hypotenuse on the bottom of those. Our cosine of B is our adjacent side over hypotenuse. So adjacent to B is 8. And your hypotenuse is still 10. And your tangent of B, tangent is opposite over adjacent. So tangent is your opposite side, which is 6, over your adjacent side, which is 8. And again, I'm not going to be overly picky about whether you left those as fractions or whether you turned them into decimals or whether or not you reduced your fractions. That's not the main point right now. You guys are in geometry and you know how to reduce fractions. It's okay if you didn't this time. Okay, so those are our 6 trig ratios, and really the big thing is, again, not getting them flip-flopped around. And you may notice we have some repeats. So your cosine up here should be the same as your sine down here. Your sine and your cosine should be the same. And these two are going to be flipped. So if you're looking at that going, must be those are the same numbers. You're right, some of them are. Some of them should be the same numbers. That's okay. And that's happening because your adjacent side, if you're talking about B, is the same as your opposite side when you're talking about A. So that's why these two are going to end up being the same. And these two are going to end up being the same. And these two are just the same fraction, but flipped. Okay, so that should happen. Don't freak out if it does. All right, let's do one more of those. So we got another triangle. And again, we're just making some fractions. So I'm just going to put a little fraction bar on all of these. And again, which sides are opposite and which sides are adjacent depends on which angle you're talking about. This is always your hypotenuse. So your hypotenuse is always across from your right angle. It's always your longest side. Okay, so your sine is your opposite over hypotenuse. So if we're looking at n, if we're looking at this one, your opposite side is the one that's not touching it. 12 and 13 are touching it, so 5 is not. So that's your opposite side. Your adjacent side is the one that is next to. And you should end up with one of each. You shouldn't have 2 adjacent sides, because your hypotenuse doesn't count. Okay, so if we're looking for the sine of n, your sine is your opposite over your hypotenuse. So opposite is 5. And your hypotenuse is 13. So anything that's over hypotenuse, you can really just go ahead and fill in those 13s right away. So they just be 13 sines and cosines are both over your hypotenuses. So that should just be over 13 automatically. So these two and these two, the same thing should be on the bottom of those. Okay, and then our cosine of n. So if we're looking for our cosine of n, cosine is your adjacent side over your hypotenuse. So we've already got 13 on bottom. Our adjacent side is 12. That's terrible too. That's better. That's better too. Okay, and then your tangent is your opposite side, which we said was 5, over our adjacent side, which we said was 12. And now we're going to flip-flop angles. So now we're talking about angle P. So watch out for which angle you're talking about there. So if we're looking at angle P instead, I don't know if you can hear my cat sliding around the floor out there. If you're looking at angle P instead, then your sine is your opposite over your hypotenuse. So opposite and adjacent flip if we're talking about a different angle. So now this is your opposite side, and this is your adjacent side. So the sine is your opposite over your hypotenuse. Cosine is your adjacent over your hypotenuse. And tangent is your opposite over your adjacent. Okay, so that's the first thing we're doing with those is just going and filling in some fractions. Not particularly hard as long as you jotted down the thing you're filling it into earlier. Just a bit long, which is why there aren't as many problems below. Okay, now, Before we get into the next thing, you may have noticed on your calculator there are buttons that say sine and cosine and tangent, although they'll be abbreviated sin and cos and tan. In order for anything we're doing next to work, your calculator has to be in degrees. So if you see a little degree button on the screen of your calculator, you're good. If you see a little thing that says RAD, you're going to need to change your calculator to degrees. If you're not sure whether your calculator is in radians or degrees, go ahead and punch the button that says tangent. Don't actually punch it, just press it. So press the button that says tangent, type in 45, and see if you get 1. If you get 1, your calculator is in degrees, you're good to go. Ignore this next part. If you didn't get 1, and you got some weird decimal like 1.6919 something, if you got that, your calculator's in radians, you're going to need to figure out how to change it to degrees. Most of them will have a radian degree button somewhere, so look for something that says RAD or DEG, or maybe R and D. If you have a calculator that you're using on your phone, so if your calculator looks like this, there's a little button there that says degrees. So there you go. You need to press the button that says degrees, and that'll change it to degrees. So if you're using your calculator on your phone, it should look like that. If you're using the calculator that pops up automatically when you type a calculator into Google Chrome, there should be a button near the top there that says RAD, So there should be something that looks like this. If you're using a graphing calculator, it's under Math, I think. No, it's under Mode. If you're using a graphing calculator, it's under Mode, and then you're going to need to scroll down to either degrees or radians. If you can't figure out how to change your calculator to degrees, just email me with a picture of your calculator, and I'll show you where it is. Unfortunately, every calculator is just a little bit different, and I'm not entirely sure which one you guys have. Honestly, most of you guys are probably just using the one that's on your phone. So if you are, it's right there. It should say RAD and then DEG, and then just click to change it from one to the other. Again, if you're not sure if it's in radians or degrees, type in tangent of 45. It should give you 1. Do that before you go on to anything else that we're doing, because in order for anything else that we're doing to work, that button has to be in degrees. It's not going to work if you're in radians. We'll get to radians eventually, but not right now. Okay, if you're still continuing on rather than pausing the video at this point, I'm going to assume your calculator is in degrees. And I'm going to change my degrees. There. Okay. So the reason it needs to be in degrees is because all of the angles that we're looking at right now are going to be in degrees. Radians is just another way of measuring angles. So kind of like inches and centimeters, you want to make sure that you're dealing with the right one and the same one that's being talked about in your problem. You don't want to be doing a problem in inches and you'd be thinking about centimeters and stuff. So that's what radians are. We just want to make sure that we're measuring in degrees right now. The reason we want that is because if we're looking at this triangle, and we have an angle here, and we want this side, we're going to be using one of our trig ratios to figure out that side, and we're going to eventually need either the sine, cosine, or tangent of that 35. So if we're looking at this angle, we're going to figure out which sides we have. We know we don't have our hypotenuse. We have the one that's next to our angle that's not our hypotenuse, so we have our adjacent. I can spell adjacent. We have our adjacent side. And we're looking for our opposite side. So if we've got our opposite and our adjacent side, if we're thinking back to so, ka, toa, and you're looking at your opposite and adjacent side, we know our tangent is our opposite side over our adjacent side. So your tangent of that angle, and instead of calling it angle A or angle B or angle whatever, I'm going to call it the tangent of 35. And that's going to equal our opposite side, which is x, over our adjacent side, which is 10. Now, this is where you need your calculator, because the tangent of 35 is just a number. So if I punch in tangent of 35, you get a decimal somewhere around 0.7002. If you didn't get that number, your calculator is probably in radians and you're going to need to change it to degrees. Do that before you do the homework. Got it? Okay. Do not do the homework with your calculator in radians. It will mess up everything. Okay, and now we're going to take this times 10, and we're going to take that times 10, which gives you about 7 over here. Technically 7.002, but we're going to ignore that 0.002. So that tells us that side of our triangle is 7. And in general, I know I keep saying things aren't drawn to scale, but in general, if you're looking at your triangle, and we know this is our longer side because this angle's got to be 55, because that's a right angle. So if we know this side has to be longer than this side, we'll make sure we get a number that's somewhere in that ballpark. So we know we want to end up with something smaller than 10. 7 is smaller than 10. That fits the bill. And we're good. Okay, let's try another one. If we've got 58 degrees here, if we're looking at this angle, again, your longest side is always your hypotenuse. So that's your hypotenuse. And the side across from our angle, the one that's not touching it, that's our opposite side. So if we're thinking SOHCAHTOA, you're going to get sick of me saying SOHCAHTOA. If we have our hypotenuse and we want our opposite side, opposite and hypotenuse is your sine. So this time we're looking at our sine. So our sine of 58 is our opposite side, which we're looking for, over hypotenuse, which is 18. And this is where you're going to want to grab your calculator, hit your sine button, and punch in 58. Which gives you 0.848. And then if we want to get rid of dividing by 18, we're multiplying by 18. That's 18. Gives you about 15.3-ish. And again, that's smaller than our hypotenuse, which our other two sides should be, because your hypotenuse should be your longest side, so we're in the right ballpark. Cool. Let's do one or two more of those. And really the big thing here is just figuring out which of the three things you want. Do you want your sine, your cosine, or your tangent? And you want the one that goes with the sides that you have and the sides that you're looking for. So if I'm looking at this angle, I'm going to figure out which sides I have first, and the one across from your right angle is always your hypotenuse. And then this side isn't touching our 25-degree angle, so that's going to be our opposite side. So this one is sine again, because SOHCAHTOA, your sine is your opposite over your hypotenuse. So really, once you figured out which one of these three things you want, you're probably good. So our sine of 25 is our opposite side, which is 7, over hypotenuse, which is the thing we're looking for. And then you're punching in the sine of 25, which gives you about 0.423. And I know there are more numbers, but in general, 3 decimal places is plenty. Okay. What do we do with that? Because we can't just divide by 7. I know it's tempting to say, okay, well, 7's at the top, we're just going to divide by 7, but that gives you a 1 over x. That's not what you want. So instead of dividing by 7, we're going to multiply by x. That's going to cancel out this x. And now we got 7 equals 0.423 times x, so we're actually going to divide by that 0.423. So 7 divided by 0.423 gives you about 16.5-ish. Okay, and again, we're looking for our hypotenuse, and this is our shortest side by quite a bit, so it's 16.5. Yeah, that's in the right ballpark. Okay, one more. So we got a 31-degree angle here. We've got, again, our hypotenuse. Your hypotenuse is a freebie. It's always the one that's across from your right angle. That's a terrible H. So we got our hypotenuse. We're looking for the side that's next to our angle, not opposite from it. So this is our adjacent side. So SOHCAHTOA. So we have our adjacent, our hypotenuse, so we want our cosine. That's a C and an E there. So the cosine of 31 is your adjacent side, which is x, over your hypotenuse, which is 20. Cosine of 31 is about 0.857. And then we're getting rid of dividing by 20 by multiplying by 20. Times 20 is about 17.1-ish. And again, we're in the right ballpark. Your hypotenuse is 20, so our sides both have to be shorter than that. This is a smaller angle, so that means that's going to be a bigger angle over here, so longer side over here, 17. Okay, we're in the right ballpark. So once you've got your side, just go ahead and double check, look back at your picture, see if that answer makes sense. If you did something and got a really small decimal, something went wrong. Probably, unless all your other sides are really small decimals. Alright, so that is it for part 1 of trig. The next assignment is actually going to be about part of this section and then also the next section, because the next section is word problems, so I only threw in like 1 or 2 of those. So that's why I split this one up, because I mean we're at 21 minutes already. This one's already pretty long. So that's the first part of what we can do with trig. In the next section we're going to be talking about finding angles instead. So make sure you got this one first. I will see you in the next section.